Okay. Now mathematical practice for chapter 7. Amanda looks at 1 kilogram bag of jelly resting on a table. Of jelly beans resting on a table. Calculate the amount of force that the table exerts in the bag of jelly beans. We talked about Newton's third law, that there's an action force and there's a reaction force equal in magnitude and opposite in direction. Now, there's a 1 kilogram bag of jelly beans resting on a table. What the force that the table exerts on the bag?
The force equal the force.
It should be 1 kilogram.
10 Newton.
The force here is talking about the bag, it's the mass times the acceleration. What is the mass of the bag?
It's 1
kilogram.
And the acceleration?
10 meters per second.
It's gravity, it's 10.
10.
Why it's 10?
Because of the gravity.
Is it 0 because it's resting?
Yeah.
Yeah, because it's resting. But then the force will be 0.
Yeah, I told you it is resting on a table. It's not
so the force will be 0 too.
So
there is no force.
No, it is exerting a force on the table, but the object itself is in rest. Doesn't it differ in two different reference frames? Isn't talking about the table and talking about the object two different things?
Yes, between
like the object
and the table.
At rest.
The object is at rest.
Actually, but the table will be 0 too because it won't remove the bag.
Sorry?
The table will be 0, the force of the table will be 0, so because of that, the bag will be at rest.
No, the force on the table is not 0. The force on the object is 0. The force on the table is 10.
It should be 10 Newton, which is 1 kilogram.
Yeah. Because the forces act on two different objects. On the jelly beans, the net force is 0 because the normal force.
So what does it mean? That means that the weight of the bag exerts a force on a table.
Yes.
No, but teacher, the question asks for the force that the table exerts, not the bag.
No, wait,
it should be opposite.
By the third Newton, we saw that the force from the bag to the table is negative, the force from the table to the bag. So I want now to find the force from the bag to the table. Then after I find this force, I will say it's negative, then I will find
it's
force from the table to the bag. Now, it is 1 kilogram. And so the only force that's acting here is the weight of the bag. So the acceleration will be 10 or 9.8. So it is 10 Newton. This is the force
from just because of the gravity?
No, not because of the gravity. The force, we say that if there's a bag here, there's a force acting on the table. The only force here will be the weight of the bag. The weight of the bag will be the acting force. So which is 10 Newton. So this is the force from the bag to the table. Now what about the force from the table to the bag?
But here the weight is 1.0. The weight is 1.0.
Not kilogram. This is the mass. Kilogram. This is the mass of the bag. So it will from the table to the bag, it will be 10 Newton. So the force that the table exerts on the bag will be also 10 Newton. Now, how does this compare with the force that the bag of jelly beans exert on the table? How we can compare it? Look at these two numbers here.
Equal and opposite.
Equal.
And opposite in what?
Direction.
Direction. Like teacher, you mean since it is the mass, so it's not the weight, so you make it 1.0 times 10 to make it mass?
No. Mass, the unit of mass is in kilogram, but the unit of the weight is in Newton.
Oh, yeah, okay, teacher, thank you.
So
Teacher,
here,
so here it will be negative 10 Newton.
yeah. Oh, sorry, yeah. So they have a equal in magnitude and opposite in direction.
Teacher, actually, this one that we took when we convert Newton to the weight and weight to the Newton, right? By multiplying 10 or dividing 10.
Ah, yes, or m times g.
Yeah.
Okay, now here. What will be the acceleration of recoil when a 60 kilogram person on roller skates pushes against a wall of the force of 30 Newton? They asked me about the acceleration. Here, the mass
Force.
of the force is 30 Newton. The mass is 60 kilogram. The axis of recoil when a 60 kilogram person, so there's a person here, his weight is 60 kilogram. He acts on the roller skates, pushed a wall with a force of 30 Newton. What will be the acceleration?
So it's 30 Newton
over
equals
mass.
60 kilograms.
Sorry. F is m times a. M is 60. The force is 30.
So it's force over mass.
So it will be 30 over 60, which is 0.5 meter per second square. This is using F equal m times a.
Teacher, is this the acceleration to the wall?
Yeah.
So they're asking about the acceleration of the recoil. Is it like in the opposite direction?
Yeah, here you can use, but he just solve it shortly, that the force from, using the, I'm here, using the third law, we say that the force from a wall to the, I mean, no, here, that the force of the, the 60 kilogram person of roller skate push against a wall with force. So this is the force from the person to the wall, which is equal the force from the wall to the person. Okay.
So it's going to be negative half over here because it's the opposite direction.
Yeah, or because, yeah, okay.
Asking about the
Teacher, can I just say the acceleration because it's not asking about the third Newton law.
Rose, acceleration is a vector. It needs to include direction.
You have to say yes. You have to say if it's backward or not downward. But see, I want you just, they asked me about the acceleration. You can say it is 0.5 and backward if it is written backward. If it is no, just say 0.5 meter per second square.
Okay, teacher.
Now, these two questions, it is from the ending of chapter 7. Okay.
Oh, yeah.
Now, these questions here, 1, 4, 7, and 9, if you go back at the end of the book, page 853, I think. Okay, you will find more exercises, more practice for each chapter. I choose 4 from them to solve it today.
Teacher, do you have the model answers for them in your book or no?
Yeah, but just the final answer.
Can you send it for us, please?
Okay, but remind me later on.
Okay, teacher, thank you.
Okay. Look at this one here, number 1. When a boxer in the gym punches a heavy bag of mass 60 kilogram, the bag moves from rest to a speed of 2 meters per second in 0.5 seconds. So here, there's a person, a boxer here in the gym, punch a bag of mass 60 kilogram. The bag, so the mass here is 60 kilogram. It moved the bag from rest, so the initial is 0 and V final is 2, and the time here is 0.5 seconds. Show that the force of the impact on the bag is about 240 Newton. I want now here, they give me the final answer, which is 240, but I want to show that the force of the impact on the bag is about 240 Newton. As you said before, the force is M times A, which is the mass. What is the acceleration here? I need to find it.
V
final
minus V initial
over
over time.
What is the mass here?
60.
It is 60. V final 2 minus 0
2 minus
over
over
0.6.
4.
2 over half is 4 times 60. It is 240 Newton.
Actually, for this one, it needs to have an essay, not choices.
Sorry?
For this one, it should be an essay. So might we
هلا
have in
ال physics, I don't know, maybe some questions with multiple choice and the other will be essay. Maybe for the
Teacher
math,
will have 40 questions or no?
no, I don't know. I didn't write it. I'm not only now writing math.
Okay.
I'm finished U and grade 8 and I have grade 11.
Make it easy.
Okay, now listen. Question 4. A 65 kilogram astronaut in the space station. So before that, let's read step by step. The mass here of the astronaut is 65 kilogram. Kicks a soccer ball with a force of 13 Newton. So there's a man here, kicks the ball with a force equals 13 Newton. Show that the astronaut accelerates backward in 0.2 meter per second square.
So the acceleration is 0.20.
So I want now here to show that the astronaut accelerates backward at 0.2.
It will be negative 0.20.
Here, the answer is negative 0.2, but I want to show how negative 0.2. How it is backward 0.2.
Find the acceleration that he impacts on the ball, and then it will be the opposite on the man.
Yeah. Now here, what is the force?
It's
13.
13 Newton.
It is the force of the astronaut or the force of the ball?
No, the force of
It
the
is
ball.
the force of the astronaut on the ball.
Yeah. So the force of the astronaut, let's say as A, equals 13 Newton. So the force of the ball, it will be what?
Negative 13
Negative
Newton.
13 Newton. Thank you. Now, how can I find the acceleration now?
It's
F equals
4
MA.
over
F equals MA, and we're going to substitute.
What I have to replace F?
Negative 13.
F with negative 13,
And M 6.5.
65. A.
65.
So the acceleration will be negative 0.2 meter per second square. So what does it mean?
It means that the force equals the force, but in opposite direction.
That the astronaut, accelerate with 0.2 meter per second square, but backward. Is it clear?
Teacher, is it the same for the third Newton law? That force equals force, but in
Yeah.
opposite
Here,
direction?
this is for the Newton law. But
Yeah.
I sometimes use the second and the first law.
Okay.
Now, number 7 here. Cart A and B are connected by a compressed spring. Cart A has a mass of 0.25 kilogram. And cart B has a mass of 1 kilogram. The spring is released. Show that cart A initially moves 4 times as fast as cart B. So here, the force from, here they have two forces. The force from A to B, from cart A to cart B, equals the force from cart B to cart A in opposite direction. Okay. Now, we said also the force is M times A. M times A. But here we have the mass for cart A, and here we have the mass for cart B. Then the mass of cart A is 0.25 times the acceleration. The acceleration here, we can say it is V over T. And here we say it is 1, the mass of V is 1, times the velocity over the time. Then, since they are compressed each other at the same time, so I can say that the time is neglected. So 0.25 velocity of cart A equals 1 the velocity of cart B. You want now to say that, show that cart A initially moves 4 times as fast as cart B. So
just divide both sides by 0.25
yeah.
and cart
Here,
A will be.
yeah, so we say that now as a, let's write it as 1 over 4 VA equals 1 of VB over 1 over 4 over 1 over 4. So VA it will be the reciprocal of 1 over 4, which is 4 VB. So the velocity, or we can say that the cart A moves 4 times as fast as B. Why I use the velocity, not the acceleration? Because I said as fast, so fast, I'm talking about the velocity. So I need to replace it with the velocity.
What if you remove the time?
Here they cart initially. I mean that at the same time. You can base initially like it is at rest. Sorry, at the same time, you can say neglect the time.
Okay.
Teacher, how did you get VA equal for VB?
Okay, I will repeat it. We said now 0.25 V of A equal V of B. I want now to write it as VA equal something to VB. What I have to do, I have to divide by 0.25 by 0.25. Then V of A equals VB over 0.25, or we can say over 1 over 4. If you want to divide anything into a fraction, you will change a decimal to be a multiply, and you will write the reciprocal of 1 over 4, which is 4 over 1. So that's why we say that V of A is 4 V of B. So that means cart A moves 4 times as fast as cart B.
Okay. Thank you, teacher.
Yeah. The last one here. Daniel, his mass is 40 kilogram, and Justin, his mass is 30 kilogram. Face each other at rest while wearing roller plates. So here there's a man. His name is Daniel. he face Justin. Daniel, his mass is 40, and Justin, his mass is 30. Face each other at rest while wearing a roller blades. Daniel pushes Justin with accelerate him at 1.6. So let's write as mass of Daniel is 40, mass of Justin is 30. Now Daniel push Justin and accelerate him at 1.6. So the 1.6 will be the acceleration of whom? Justin, thank you, because he accelerate him. So this is for Justin. Now shows that Daniel accelerate in the other direction at 1.2. So I mean find the acceleration of Daniel. They have facing, or they have meeting each other, so they are connecting with each other in third Newton. So the force of Daniel equal negative force of Justin. Justin, his name? Oh yeah, of Justin. Now the force of Daniel will be the mass of Daniel times the acceleration. And of Justin, it will be mass of Justin times the acceleration of Justin. The acceleration of Justin is 1.6, and mass of Justin will be 30 times negative equal m times d. M is 40, and this is an acceleration of Daniel. So 40 times 1.6 is negative 48 equal 40 times acceleration of Daniel.
So divide by 40.
Divide by 40. Divide by 40. So you'll find that acceleration of Daniel will be negative 1.2 meter per second square.
Like just they give us the answer, but
the acceleration of Daniel 1.2 in the other direction, because Daniel act a force to Justin, and Justin will have the same force to Daniel, but in another direction. If we said, since that m times a, since the force is a vector quantity, so and the mass is a scalar one, so if I need to talk about the direction of the acceleration, I need to talk about the acceleration of the force, or the acceleration of the force, I need to talk about the direction of the acceleration. So here, mass is a scalar quantity, the acceleration and the force will be a vector. So direction of the force will be the direction of the acceleration, and the direction of the acceleration will be the direction of the force.